Hello, future engineers. Today, we'll explore the critical world of storage tanks, fundamental structures across chemical, petroleum, and water industries. Our focus will be on categorizing them by their key design elements. We will examine above-ground versus underground installations, each with distinct advantages for safety and space. Furthermore, we will analyze the primary tank shapes: cylindrical tanks, both atmospheric fixed roof and internal floating roof types, and spherical tanks, which are ideal for high-pressure liquefied gas storage. Let's get started. What is a storage tanks? Storage tanks are stationary vessels designed for the safe containment of fluids, including liquids, gases, or slurries. They are a critical piece of infrastructure across industries like oil and gas, chemical processing, water treatment, and agriculture. These tanks vary significantly in size, design, and construction material based on their contents and required pressure conditions. Key types include atmospheric storage tanks, such as fixed roof and floating roof models for large liquid volumes, and pressurized storage tanks, like spherical vessels or bullets, for holding liquefied gases under pressure. The primary engineering objectives are to ensure structural integrity, prevent product loss, maintain material quality, and meet stringent environmental and safety standards. A fixed roof tank is a cylindrical storage vessel with a permanently attached cone or dome roof, primarily used for storing large volumes of non-volatile liquids at near atmospheric pressure. Application and usage. Its key application is in industries like petroleum, chemicals, and water treatment for storing products with a high flash point, such as crude oil, diesel, water, or certain chemicals. It is unsuitable for highly volatile liquids due to its lack of pressure sealing, as breathing losses can occur from vapor expansion and contraction due to temperature changes. Materials of fabrication. These tanks are almost exclusively constructed from carbon steel for its strength and cost-effectiveness. Stainless steel or special alloy linings are used for corrosive products. The roof and shell are typically welded steel plates, and the tank sits on a reinforced concrete foundation. A floating roof tank is a storage vessel featuring a roof that floats directly on the surface of the stored liquid, rising and falling with the liquid level. Its primary application is in containing large volumes of volatile liquids, such as crude oil, gasoline, and other petrochemicals, to minimize evaporation losses and reduce the risk of flammable vapor release. Usage is focused on atmospheric storage, where controlling emissions and product loss is critical. The design significantly limits vapor space. Construction is predominantly carbon steel for the shell, deck, and pontoons. For corrosive services, aluminum or stainless steel roofs may be used. Critical seals around the roof edge are made from specialized elastomers or composite materials resistant to the stored product. A dome roof tank is an atmospheric storage tank featuring a fixed, geodesic, dome-shaped roof. Its primary application is for storing volatile liquids, serving as a modern alternative to traditional external floating roof tanks. It is widely used in the petroleum and chemical industries for products like gasoline and ethanol. The key usage advantage is its enclosed design, which significantly reduces weather-related product loss and emissions compared to open-top designs, while avoiding the maintenance issues of internal floating roofs. The tank's main shell is typically constructed from carbon steel. The dome itself is often fabricated from lighter materials like aluminum or glass-reinforced plastic, GRP, to reduce structural load, supported by a steel framework. A bullet tank is a horizontal, cylindrical pressure vessel with hemispherical heads, designed for storing liquefied gases under moderate pressure. Its primary application is for products like liquefied petroleum gas, LPG, ammonia, propylene, and other volatile liquids that require containment between 5 to 25 bar. These tanks are used in distribution terminals, industrial plants, and filling stations where smaller, pressurized storage is needed, as opposed to large atmospheric tanks. Fabricated predominantly from high-strength carbon steel or low-temperature carbon steel to withstand internal pressure and prevent brittle fracture. The cylindrical shell and heads are precisely welded, and the entire vessel is often mounted on saddles to accommodate thermal expansion and contraction. A spherical tank, or sphere, is a pressure vessel designed for storing highly volatile substances at elevated pressures. Its primary application is in the petrochemical and oil and gas industries for products like liquefied natural gas, LNG, propane, butane, and other refrigerated gases. The spherical shape is used because it offers the optimal volume to surface area ratio and distributes internal pressure stresses uniformly across its surface, making it immensely strong and efficient. These tanks are fabricated from high-strength, low-alloy carbon steels or specialty metals like 9% nickel steel for cryogenic service. The construction involves forming and precisely welding curved steel plates to create the seamless sphere, which is then supported by a cylindrical skirt attached to its equator. A cryogenic tank is a highly specialized, vacuum-insulated pressure vessel designed for storing liquefied gases at extremely low temperatures, typically below -150 degrees Celsius. Its primary application is for industrial gases like liquid nitrogen, LIN, oxygen, LOX, argon, LAR, and liquefied natural gas, LNG. These tanks are used across aerospace, medical, energy, and manufacturing sectors where large volumes of gases need to be stored and transported efficiently in their liquid state. Construction utilizes double walls with a vacuum-jacketed annular space to minimize heat transfer. Inner vessels are fabricated from austenitic stainless steel or aluminum alloys to retain toughness at cryogenic temperatures. The outer shell is typically carbon steel, and the insulation often involves perlite or super insulation multi-layer foil. An underground storage tank, UST, is a vessel buried below grade to store liquids, primarily petroleum products like gasoline or diesel, and sometimes chemicals or water. Its key application is at retail fuel stations, to save surface space and minimize environmental exposure. Usage prioritizes safety and environmental protection, preventing spills, reducing fire hazards, and maintaining a stable product temperature. They are subject to stringent regulatory standards for leak detection and corrosion protection. Modern USTs are predominantly fabricated from corrosion-resistant materials. The primary choice is fiberglass reinforced plastic, FRP. For steel tanks, they must be clad with a corrosion-resistant coating and be equipped with CAFETIC protection systems to prevent deterioration. The installation includes a secondary containment barrier for leak prevention. Please answer all questions in your own words, based on your understanding of the lecture materials. Your responses must be original and clearly reflect your grasp of the concepts. Submit your completed answers in writing, scan and paste, using PDF format via email to yasmi@uinkl.edu.my. Please use the subject line, Storage Tanks Assignment, your full name, your student ID. Ensure your submission is made before the deadline.